if we look at the following here, we are told that we have Simon who either walks or cycles, okay? So it's either Simon is going to walk or cycle. This thing is equivalent to something like this. We have learners who are using scholar transport, okay? So we can say the learner is either using scholar transport or the learner is not using scholar transport. And then here, Simon either walks or he cycles to school, okay? When he cycles to school, the probability that he is on time is 0.9. And then they say, but if he walks to school, the probability that he's on time is 0.8. He cycles to school 60% of the time. And then they say, we should draw a Venn diagram to represent this information here. We have a situation whereby we have Simon who either walks to school, okay? Or Simon can either cycle. And then you can already see cycling and walking, they are mutually exclusive events. They cannot occur at the same time. Because it's either Simon is cycling. Okay? If it is not cycling, he can't cycle and walk at the same time. It's not. So we don't have an and. Does that make sense? Okay? So event number one, it means what we are going to be looking at is either the person is cycling or what, or walking. Okay? And then after that, they speak about the probability that is on time. This is something where they are speaking about someone being on time. Okay? Now, that's another event. A person can either be on time, okay? Or a person is going to be what to be? Yeah, it's either they are on time or they are not on time. Does that make sense? So we need first, this is a conditional, as I'm saying, this is conditional. There's something that needs to occur before the other one occurs. Which one should occur first between the two of them? Which one should happen? Should you walk first or be on time first? Which one is going to come first? Yeah, we can't speak about you being on time or late if you have been walked or cycled. We are using observation. So there's a certain event that needs to occur first. So as a learner, you need to come and read here. Okay, we have all these events that are taking place there. Which one is going to come first? So we agree with a person can either be on time or a person can be late if only they've walked or what or cycled. The first question says that draw a tree diagram to represent this information. So what are we going to say here? Usually, we're not going to say always. Usually, you will see the first event is going to be given on the first sentence. At least Simon either walks or cycles. So we are looking at event whereby the person is either walking or what cycling. So there are two possible outcomes. Outcome number one is either the person is walking. Okay. Outcome number two is either the person is what is cycling. How do we represent that get tree diagram here? Now we already know which we are going to say, okay, it's either we're going to have something like this. It's either the person is walking. I'm going to use W. Okay. If the person is not walking, the person is going to be what to be? Cycling. And then these two events are mutually exclusive and then they are also complementary. Meaning in other words, Murok, when I add this one plus this one, they're going to give me a probability of 1. Now remember, a probability can be given as a decimal. Okay? It can be given as a fraction. It can also be given as a what? As a percentage. Okay, now they say when he cycles, you see now, when he cycles, it means go in this direction. I think the person can either cycle and then the person can either walk. Okay? When he cycles, they say take the cycle line, go in that direction. You get what I'm saying here. The person either walks or cycles. Okay? When he cycles, he's either on time. Again, so we say if he's cycling, he can either be on time. So we can say OT, yeah? And then we can say then OT not. Let's put it that way. Or we can, depending which one about 10, we'll check which one, what is the language that they've used. If they use late, we'll use late. If they said not on time, we'll use not on time. When he cycles, he is on time. But if he walks, you see the other one. If he walks, he can either cycle. If he's not cycling, he's doing what? He's walking. Again, if he walks, he can either be what? He can either be on time, okay? Or he can either be not on time. Are we still together again? Now let's go and put in the probabilities there. They are saying he is on time. Remember what did they say? The probability that he is on time is 0.9%. when he cycles. Okay. So when he cycles, there is going to be 0.9% that is on time. Yeah, 0.9. 0.9. When he cycles, the probability that he's on time is going to be 0.9. And then on time, 0.9. What is going to be not on time if he cycles? This one is going to be 0.1. How do you get 0.1? At least it said on time and not on time, they are complementary and then they are mutually exclusive. Okay? So if I add this one and this one, they're supposed to give me what? Does it make sense? Okay. If he walks, if there's an if statement here. If he walks, he is on time from, the probability that he's on time is going to be 0.8. Now, if he walks, okay, there's going to be 0.8% which is on time. If there's 0.8% which is on time, what is going to be not on time when he walks? This is going to be what? 0.2. And then they went on to say he cycles to school 60% of the time. Cycles to school 60%. Okay? It's 0.6. Okay? Yeah, we are going to change this one because we've already used decimals. If either we use percentage or we use decimals, we can't use both of them. Stick to one. So we're going to change this 60% and then we're going to make it to be 0.1,6. And then what are we going to put here? It's going to be 0.4. And then let's go and write our possible outcomes. Then what are we going to have as our possible outcomes? He walks and then he's on time. Okay? He walks on time not. Okay? He cycles on time. He cycles on time not. And then how do you get this one off? You get it by saying 0.4 multiplied by 0.8. This one. This one, 0, multiplied by 0.9. Last one is what? 0.6 multiplied by 0.1. And then you will see which the challenge is going to be here, guys. It's going to be here, which we just have to know how to get the Venn diagram. If we can get the Venn diagram, then we can determine the questions. They say determine the probability that he is late for school on a day chosen at random. He's late. Okay, they are using late, not on time. Instead of using not on time, they are using late. So we'll come and change this thing and put late here. So we'll come and say, okay, yeah, instead of not on time, they're talking about late. So we'll come and say, this is late, this is late. So in fact, here, when we write this thing here, we'll write it as late, late, and late. We're still fine. And then what is the probability that he's late on a particular day? Now he can either be late when he's walking, okay? Or he can either be late when he's what? Cycling. So you go and check. When can this person be late? He can either be late when he's walking, or he can either be late when he's what? When he's cycling. So what are you going to take for this one? You're going to take this one and this one because both of them have late. Does it make sense, man? And then I want us to try this one and then we'll come back to the other one. Are these being independent events? Let's try this one as an activity.